All right, I guess we'll get started. Can everyone hear me? Sound is good? All right. So I'm Wolfe Gordon. I work at DigitalOcean. These days, I actually work on our Kubernetes team. I work on our managed Kubernetes product, so I'll be here all week for KubeCon. Before I started working on the Kubernetes team earlier this year, I worked on our block storage team at DigitalOcean, doing storage stuff. And before that, I worked at EMC, also on storage stuff, so I've been in the storage world for a while. I'm going to talk today about some work that I did when I was on the storage team to enable us to test Ceph using our own cloud resources. So a little bit about DigitalOcean for those who aren't familiar with us. We're a public cloud provider. We started in 2011, and we offer kind of the things you'd expect from a public cloud. Virtual machines, which we call droplets, and those are QEMU, KVM based. Block storage, which you can attach to virtual machines, which is Ceph based, also S3 compatible object storage, Ceph based. And then higher level offerings like our managed Kubernetes, managed databases, managed load balancers that are built on top of those primitives. And all the network stuff that goes along with that, firewalls, DNS, floating IPs, all that good stuff. Like I mentioned, all our storage products are based on Ceph. We've had Ceph in production for about 3 years. We launched block storage in mid-2016, which was shortly after I started at the company. And about a year later, a little over a year, we launched our S3 compatible object storage, which is called Spaces. We launched that in the late 2017. So we have a fairly big Ceph deployment at this point. We have 21 Ceph clusters around the world in 9 different data centers. It's about 40 petabytes of raw capacity in total. Those numbers might be a little bit off. I added them up really quickly from some graphanographs, so don't hold me to them, but they're pretty close. When we started using Ceph, and actually still to this day, we've been using community builds of Ceph and community releases. Haven't needed to build our own Ceph. We've really had very few problems. It works really, really well for us. We've been very happy with sort of the quality of Ceph and the feature set that it offers. And for the first 2 years or so, we really didn't feel any need to develop Ceph itself. We built some tooling around it for our own needs, our operational tooling. But in terms of building on the core Ceph, we didn't feel like we needed to do a lot of work. We made a few minor upstream contributions, but not a whole lot. As we scaled, though, we did start to feel like we needed to work on Ceph and build some Ceph development capability in-house. In particular for our block storage product, since we don't control the workloads that run on it, those are customer workloads, we really wanted to have more quality of service knobs, be able to prevent a customer with a heavy workload from saturating a cluster, have a bit more control and offer users a more consistent performance experience. So that was one thing we wanted to build. On the object storage side, we started hitting some scale limitations of our GW, some bugs in our GW as we launched and scaled our object storage offering. So we realized that we were going to need to do some Ceph development work and really bring some of that capability to our storage team at DO. And we really wanted to solve our own problems. That meant we needed to do a few new things that we hadn't been doing before. For one thing, we needed to build Ceph ourselves. That was pretty easy. We spin up a build VM, we run make. It's really pretty easy to build Ceph packages. We also needed to be able to run those custom builds in our staging clusters or in production. Again, that was pretty easy. We already had our own package repositories that we were pulling community packages into. So putting our own packages there was really simple. The big thing that we needed to do that we didn't have a simple solution for was testing our changes. One of the nice things about running community builds is that you know that they've been tested and they are going to be of high quality. They've had lots of run hours, people running integration tests on them, people running manual tests on them. So we wanted to have that same confidence, or at least close to the same level of confidence in changes that we were making to Ceph, especially if we were going to run them before they were fully upstreamed. And that's really what this talk is about, is how we set ourselves up to run tests on Ceph on our infrastructure. So I'm guessing a lot of the people who decided to come to this talk already know something about the testing tools that there are for Ceph and how you test Ceph. but I'll go over a really brief overview anyway. First of all, there's a framework called Teuthology, and that's the integration testing framework for Ceph. It's used to build the integration test suites, which are in the Ceph repository. And Teuthology can do a whole bunch of things. It can configure Ceph clusters on a set of nodes, run I/O in various ways, inject some faults, all the kinds of things you want a storage testing framework to do. And the usual place where Teuthology tests get run is the CPA Lab, and Sage mentioned the CPA Lab in his keynote this morning. This is a set of hardware that's maintained by Red Hat for the use of the Ceph community, and it's kind of where a lot of the Ceph testing gets done. At DigitalOcean, we didn't want to rely entirely on the CPA Lab for testing, and this was for a number of reasons. For one thing, not everyone has access to it. There's a process you go through when you are becoming a Ceph contributor to get access to the CPA Lab. We didn't want people at DigitalOcean to necessarily have to do that right away. We wanted people to be able to make changes to Ceph and run Teuthology tests on them right away on our own infrastructure. The CPA Lab is also a shared resource, so there's some contention for it. Your tests aren't necessarily being able to run right away if there's lots of tests running. That felt like something we wanted to work around. And in particular, we wanted to have a CI system that would start tests in a lab environment, automatically run integration tests on pull requests or on branches. And doing that on a shared resource didn't feel like a friendly thing to do to the community. So we wanted to build our own for that purpose. And at the end of the day, we are the cloud. We have tens of thousands of servers that we can spin up VMs on all the time. We didn't feel like we needed to take up a community resource for testing our own changes when we could avoid it. There's certain kinds of testing maybe that we'd still want to do in the CPA Lab or elsewhere. But for the most part, we felt like we could run at least correctness tests, basic integration tests on our own hardware in VMs. So I had a fairly simple plan. My plan was Teuthology needs nodes to test on. At the end of the day, that's where it runs tests, is on nodes. And different tests declare how many nodes they need for their test and how those nodes should be configured. So I felt like I should be able to write a wrapper for Teuthology or maybe a module for Teuthology that would provision VMs on demand. So when a test says it needs 3 nodes, it would spin up 3 VMs, provide them to Teuthology for testing, and then tear down those VMs when it was done. Right? This is a very cloud-like thing to do. And Teuthology had a module that used libcloud to run tests on OpenStack. So libcloud also supports DigitalOcean. Seemed like it should be relatively easy to adapt it to use our resources instead of OpenStack resources. It turns out Teuthology doesn't really work the way I expected, and so this plan kind of fell apart. First of all, Teuthology is very intertwined with a system called Paddles. And Paddles is a node reservation system and also a result repository for tests. When Teuthology goes to run a test, it requests nodes from Paddles, and Paddles tells it which nodes it can use, and then it locks those nodes in Paddles so that other tests can't use them. You can manually specify nodes to use, but it's still going to reach out to Paddles and try and lock them. That didn't really work for the case of spinning up an ephemeral set of VMs to use as your test nodes. It's kind of a mismatch. And it also turned out the libcloud module wasn't quite what I was hoping for. It was very OpenStack specific, and it really spun up an entire lab environment rather than sort of an ephemeral set of test VMs. It just didn't quite work the way I expected it would. And also, the libcloud module didn't seem to be very actively maintained. When I asked about it on IRC, the answer I got was basically it sometimes works, sometimes doesn't. It's not sort of the most tested part of Teuthology. So I was a little bit concerned about us relying on it for our CI. So I had a new plan, which was deploy a Ceph Lab internally on DigitalOcean droplets, DigitalOcean VMs. The nice thing about doing this is we can always scale it up or scale it down if we want to. We have capacity for it. And I wanted to make this process repeatable and easy to manage, so I wanted to automate it. And we figured we'd also open source that automation because we thought maybe other people would also like to test Ceph on DigitalOcean. So the pieces of a Ceph Lab, at the end of the day, are the paddles server, which, like I mentioned, does the node reservation, node lock, keeps track of nodes, and also records test results. There's also a web UI that goes along with paddles called Pulpito that can run on the same node, and it needs a database to back it. We can also run that on the same node. The second component is a head node. The head node runs a queuing daemon for queuing up tests, and it runs some worker processes that actually execute those tests. And the head node also serves as just a convenient place to run tests from, or to start tests from, because it already has the code checked out. You don't have to do it from there, but you can. The third component is the test nodes. These are the actual machines that Teuthology is going to install Ceph on, form them into sort of an ad hoc Ceph cluster, run the tests, and then return them to the pool as just nodes to use. So these can be pretty much arbitrary machines or VMs. They just need some disks, because Ceph needs disks. So having figured out sort of what the machines were that I needed, it was pretty straightforward to automate setting up a Ceph Lab using DigitalOcean droplets. I wrote some Terraform code to actually create the different resources, the droplets and the disks. And I wrote some Ansible code to do the configuration. The Terraform stuff calls out to Ansible to do that configuration. So at the end of the day, I have a single command I can run that spins up a fully functional lab for testing Ceph. And most of the rest of this talk is going to be about the sort of roadblocks that I ran into in building this automation. There were definitely some things that I had to work around to come up with a fully functional test lab in an automated way on VMs. But before I talk about those things, we're going to attempt a live demo. I'm going to show how to use the automation that I built to spin up a test lab, and we'll see if it can run tests by the end of this talk. So the URL to the source code, first of all, is on the slide there. So if anyone wants to check that out, please do give it a try and let us know what your experience is with it. Try running Ceph tests on DigitalOcean. And I'll show the URL at the end as well, for people that want to write it down. But right now, I will go over to a terminal, and we will try and see what we can do here. All right. So here I have a pretty much clean checkout of the DigitalOcean Ceph Lab repository. You can see it has a bunch of Terraform files, those are the .tf files, and it has a directory called Ansible, which holds all of the Ansible plays and roles that we're going to use to configure our Ceph Lab. I won't sort of dig into this too much because you can go and read it yourself, but it's all just Terraform and Ansible. To get started, what we need to do is create a tf-vars file that declares some parameters for our lab. So we give the lab a name. This name is going to be used in the node names so that you can see in your DigitalOcean control panel which nodes belong to which lab setup. We also have, we tell it which region we want to run in, so that's the DigitalOcean data center it's going to run in. I've put it in Amsterdam because we're in Europe. We tell it which image to use for the test nodes, so we're going to use Ubuntu 18.04 today. And we tell it how many test nodes we want. I've said 3. And if we look at our vars file, we can see there's a few other things you can customize, like how many volumes each test node should have, how big they should be, and there's also these SSH keys that it needs, and I've just put those in separate files for now because they're long and boring to look at. But with that vars file created, we just run a single command, this Terraform apply command, which I'm running under Docker, but you don't have to. We'll hit enter, and we'll see. It's going to tell me which resources it's going to create. If we look here, it's going to create some droplets, some test nodes, a paddles node, a head node, and it's going to create a bunch of volumes that'll get attached to those test nodes. And I will say, yes, please start creating them. And we'll see it start creating. We'll watch it just for a minute until it, okay. Well, we ran into I'm using the same SSH key twice, so it ran into a problem. But normally it would continue with spinning up all the nodes. I have a pre-created one that I created just in case something went wrong with the demo, so we'll use that later to actually run some tests. But that is the single command to spin up a test cluster on DO. And I'll go back to the slides now. All right, so like I mentioned, I ran into a few challenges in building this automation and coming up with an automated way to have a fully functional test lab on DO. And most of these challenges were sort of problems with Teuthology. And not Teuthology itself in terms of the part that runs tests, because that part is very flexible, works quite well, but just sort of assumptions that Teuthology makes about the environment that it's running in. And these are assumptions that have grown out of the fact that it mostly runs in the CPA Lab. So I'll talk through a few of those, and these are just some sort of examples of places where it was not conducive to running it outside of its native environment. The first unexpected assumption that I found Teuthology made was DNS. Ceph itself doesn't really need DNS for much. You can use it to configure various things, but you can also configure Ceph pretty much entirely by IPs. Teuthology, however, assumes that all of the test nodes are going to be able to reach each other by DNS names. And it only keeps DNS names in paddles. It just assumes that they're going to be there. The droplets that we're using for testing don't inherently have DNS names. That's not something that comes with a droplet automatically. So, and I didn't really want to set up like globally resolvable DNS for these test nodes. That just felt like overkill for something that should be sort of an easily expandable and contractible cluster. So my kind of hacky solution was to install DNS mask on one of the nodes. I installed on the paddles node. And we use that as an internal DNS server within the test lab environment. So all the test nodes, the head node, they all get configured to use the paddles server as their DNS server. And then I just stick all the other hosts' IPs in the etc hosts file, and DNS mask will resolve addresses from the hosts file when it's asked for resolution. This did mean in our Ansible playbooks we have to configure DNS on all the nodes, and depending on which image you're using, some of those nodes maybe use systemd, some of them don't. So there's a few conditionals in there for how to set up DNS. It was a little bit, you try it on one image and it works, and then another image and it doesn't. So there's a little bit of figuring out to do there. But at the end of the day, it works pretty well. And this is something that if we add additional distributions right now, this automation basically only supports Ubuntu. If we add additional ones, we'll have to add more conditionals there to sort of work around the differences between distributions. The next thing I ran into when I thought I had a working lab and started to try and run tests on it was this special file that Teuthology just assumes is going to be on every test node called /scratchdevs. And this scratchdevs file tells Teuthology which disks it's allowed to use for Ceph. This is I think in the CPA Lab, this is created by the provisioning stuff when they're provisioning a new node. So I just needed to create it from our automation. This was relatively easy, but it was very easy. It just listed the disks in the file. It just took a bit of debugging. It was a little bit mysterious why my tests weren't working, and this is what it turned out it was. The next trouble I ran into was, I'll explain the symptom first and then the cause, which is on the slide. I would run a test. It would go and install Ceph. It would reboot the nodes after installing Ceph, and they just wouldn't come back. It turned out they were being powered back on, but they had dropped off of the internet. The reason for this was because there is some additional Ansible automation called CephCM Ansible, which Teuthology uses to configure the Ceph clusters that it creates as part of tests. One of the things that this automation does is try and reconfigure the networking on the nodes. And that doesn't work if your nodes are in the cloud. In particular, it was trying to use DHCP to get addresses, and DigitalOcean droplets don't necessarily use DHCP. to get addresses. They have their addresses pre-configured by Cloud Init. So basically the network interfaces on these droplets would end up without addresses. You couldn't get to them anymore. I was able to blacklist these roles, the Ansible roles that it was running from Ceph Ansible. Teuthology already supported that, actually, so that was convenient. I just had to figure out exactly which ones were causing problems and work to blacklist them. So these blacklists now live in an overrides file that we have on our head node, and we just have to remember when we're running tests to always include the overrides file, otherwise the nodes might go away. As I mentioned earlier, we're running tests largely from a CI environment, so remembering to include that overrides file is easy. If we were running them manually, then it would just be something that everyone has to sort of know before they start running tests. Another related problem that we ran into is our tests were all working fine for a long time, and then all of a sudden they started failing. It turned out that something had been added to Ceph Ansible that would try and basically clear off disks before Ceph started using them. I think this probably happened as part of the Blue Store work, so there wasn't leftover stuff on the disks. This play was trying to touch a config drive on the droplets because it wasn't using the scratch devs file to figure out which disks to use. And when it wasn't able to touch that, the test would fail. So we started just having this sort of mysterious failure. Again, the solution was to blacklist that role. It's just, as Ceph Ansible progresses, we have to just keep an eye on what it's doing so that we know which additional roles we're going to have to blacklist because they won't work with our environment. In addition to these sort of challenges with setting up cloud machines to work for Teuthology testing, we had a couple of things that were more specific to our use case of testing our own builds. So that's the next couple that I'll talk about. A big one we ran into is that Teuthology makes a lot of assumptions about where Ceph packages live on the internet, like where it's going to pull them in from. And it tries to look for packages in a system called Shaman, which is basically the source of truth for all of the upstream Ceph builds that happen as part of the upstream Ceph CI. We're doing builds internally, and we have our own internal app repositories where the packages end up. So those builds aren't in Shaman. That was kind of the goal of this whole exercise, remember, was that we can test our own builds from our own CI system. Teuthology does actually support setting a direct URL for packages and avoiding Shaman altogether. It's just not the default. So I was able to do that. It was fixable. It just was another sort of thing that I had to discover how to do. Related to that one, Teuthology makes some assumptions about the paths that packages will be at for a build when you point it at an apt repository. It doesn't just find them by version. It finds them by any of the git SHA-1, the version number, or the branch name. And it actually will use all of these location methods for packages within the same run. So we have to have all of those paths available for every build. That wasn't something that we had thought of when we were figuring out our Ceph build process. But it was easy enough to add it to it. We just have to create a bunch of symlinks so that all of those packages are available at the locations that Teuthology is looking for them. I kind of expected that Teuthology would just take a version number and like install packages of that version for whichever OS it was doing, but it turns out it has all of this path building logic for them. The maybe biggest challenge that I ran into in terms of how much effort it was to fix it was that when you tell Teuthology to run tests against a particular SHA-1, it tries to validate that git SHA-1 exists in the Ceph repository. And it does this by reaching out to GitHub or git.ceph.com, depending on where the source is, and looking it up on the sort of HTTP API. So we're hosting our Ceph dev branches in a private GitHub repository for a variety of reasons. So those commits weren't in the upstream repository. They weren't in a publicly available Git repository. So I had to actually modify Teuthology to just not run this check. It doesn't actually use any of the data it gets back when it does this check. It's just checking it as like a sanity check for does this commit exist. Later, it's going to go and check out that commit using Git, and that part worked fine. So we just had to add a flag where tell Teuthology not to double check it. So we'll go back to our live demo now, and I'll show what we end up with if once our automation runs to completion. And like I mentioned, I did spin up one previously just in case something went badly, which it has. So I'm going to SSH to the head node of the Ceph Lab that I spun up earlier. And I'll become the Teuthology user. And we can see that the automation automatically checked out both Ceph and Teuthology, so that all the sources available in the places where Teuthology expects it'll be. And it's also automatically set up a Python virtual env so that I can run all of the Teuthology tools, like that, for example. And if I run a suite, I take out the dry run flag, we should see it schedule some jobs. So we can see that Teuthology is sort of up and working as expected on this node that's been provisioned by our automation. There it goes. It's scheduled some jobs. If I find our paddles node in the if I look at Terraform and ask it where my nodes are, we'll be able to find out where our lab is, and we should be able to get to the Teuthology or the Pulpito interface. We can see the nodes that it created. So there's our 3 test nodes, and we should be able to see our job queue with this 1 job, 1 queue, 3 running, or 3 waiting. And those have decided to use not Ubuntu 18.04, so they're kind of stuck. But if we had jobs that were using Ubuntu 18.04, they'd be able to run. This was something I was trying to figure out the other day, was why it wasn't filtering properly, because I had it filter properly before. But yeah, this is what it spun up. So it spun up the entire system. It is usable for tests. And one piece of future work, if anyone's looking to contribute to our automation, would be being able to spin up nodes of all the different distributions, so you have them in the same lab rather than just a single one. That's, for our purposes internally, we've mostly been testing on a single distribution at a time, but it would be nice to be able to do more than one. All right, we can go back to slides to finish up here. So just to sum things up and some takeaways from this talk, Teuthology is a really powerful test framework. It's great that we have this tool already pre-built to run Ceph tests. It really gives us a lot of confidence in the builds that we do and any changes that we make. The only trouble that we've had with Teuthology is that it does make a lot of assumptions about its environment. And this is kind of a result of it mostly being run in one place. And as we've tried to run it in different environments, we ran into a few challenges we had to work around. This is a bit of a barrier to entry for new Ceph developers. If you want to run integration tests, you need to either get access to CPA Lab or figure out all of these challenges to make it run in a different environment. So that's something that hopefully this automation that we've built and open sourced will help with, is if people want to really quickly get started with running tests on Ceph, they can spin up an environment on DigitalOcean and just start running the tests. Hopefully this is something that the community will find useful, especially as we try and grow the contributor base for Ceph. This should make it easier for people to jump in and start running tests, and start writing tests, and start making changes and writing tests for them, which is ultimately the goal. Like I said, it is available. I've got the URL there on the slide as well as my email address if you want to get in touch with me. Please do try it out. Let us know if you've got suggestions for it or want to contribute, or if it just doesn't work at all, which is a possibility. We would love to have people using this and have this something that DO can contribute to the Ceph community, since we really have got a lot of value out of Ceph. Hopefully this is something that will help the community in general start to run more tests and bring new contributors on. And that's all I have. We've got some time for questions, and I'm also around all week. If you want to chat with me, you can find me at our booth out here or our booth at KubeCon. Thanks. Yeah, so the automation that spins up the lab environment clones it and does that. We don't do that on every CI run. We have a lab that we just keep around. The nice thing about spinning it up with this automation is that if I need to replace a node because something weird goes wrong with it, for example, like the problems I mentioned where we had nodes randomly going away. I can use Terraform to just taint the node and then recreate it. Yeah, so it's a really simple way to manage the lab infrastructure. But yeah, that's what it does. Yep. Yeah, so I have contributed a little bit. I contributed the thing to have it not check git shuz. But yes, it is something we've thought about. I personally am not on the storage team anymore, so I'm not touching it these days. But I think as we grow our Ceph development capability at DigitalOcean, that's definitely something that we'll look at. Yeah, I think our goal is definitely to make it better and make it easier to run, make it easy to run in different places. So, yeah, definitely want it to be upstream. Yes, we do have developers making Ceph changes. I have made some upstream Ceph changes in the RBD mirror area, but we also have people working actively in RGW and some in RBD as well. We haven't had a ton of contributions so far, but we're gaining velocity there, so there will be more soon. Yep. All right. No other questions? I think that's all. Thanks.